guys, welcome to Staad tutorials. In this session we will be dealing with the design and analysis of an RCC building, particularly beams and columns subjected to dead loads and live loads. So initially start Staad Pro. Select new project. It is a 3D frame. RCC building is a 3D frame, so give it space and some name. Select next, finish. Now we go to geometry and structural wizard. Our building plan is as shown in figure. So you can see there are two bays of 5 meters and 4 meters in lengthwise, and widthwise there are three bays 3.5 meters, 6 meters and 1.2 meters in length. So we select frame models, select bay frame and give length as 9 meters, base as 2, one is of 5 meters, the other one is of 4 meters. Now we go to height, we give it as 3 meters for each floor, and coming to width it is 10.7 divided into 3 bays, one of 3.5, other one of 6 meters and the other one of 1.2 meters. It is 3.5. Now you need to transfer this model to main Start Pro screen. Select OK. Switch off the grid. In our figure, here there are no beams and columns, so we'll delete those. Select delete button, press OK. Yes. Now we need to shift this building frame to 5 stories. So we use translational repeat command. Go to geometry, select translational repeat, give number of steps as 5 and default spacing as 3 in global y direction. Select OK. But you need to select the entire structure before that. Now we can go to translational repeat, give number of steps as 5 in this way. So in this way our RCC building is done. Now coming to the properties, we will define rectangle property 0.35 by 0.25. Select this, select the entire structure, assign to the entire structure. Now coming to support, create fixed support, select front view, assign to the bottom nodes. Now you can view the supports are assigned. Next is we select beam cursor, select top view, give right click, go to structural diagrams, select sections outline, apply, OK. You can see the columns are in this direction. Similarly here too. But as per our figure, these are perpendicular to this, so we need to modify these 4 columns. So for that we go to property, select beta angle, create beta angle as 90 degrees, select beta 90 and select those particular columns by pressing Ctrl button. Only columns, nothing else. You can see it. Now assign to selected beams, assign yes. So once the beta angle is assigned, we can view once again the sectional outline. So you can see now that the column are modified and are perpendicular to this. So once this is over, we go to loads and definitions, load case details add, give the first one as dead load and loading type will be dead. The second one as live load and loading type will be live. Add. Select dead load. As for figure, 9-inch wall, which are outside walls, will be 9-inch walls. Will have 12 kN per meter dead load. For 4.5 inches walls, it is 6 kN per meter, particularly inside walls. Dead load on slab is 3 kN per meter square. Floor finish is 1 kN per meter square. Live load for residential building is 2 kN per meter square, and office building is 4 kN per meter square. And also the self weight is assigned. Coming to dead load, select add, select self weight, add. Coming to member load, it is -12 for 9-inch walls and -6 for 4.5 inches walls. And coming to slab load, it is 4 kN per meter square, and we need to give the Y range, which will be from 3 meters starting from first story or first floor to 18 meters, that is to the end of 5th floor or 5th story. Similarly, you give live load, which is only floor load, or slab load, which is 2 kN per meter square for residential building. You need to give the Y range from 3 to 18. Assign self weight to the whole structure. Similarly, 12 kN per meter will be assigned to outside walls by selecting control. Assign to selected beams, assign yes. Similarly, 6-inch walls to the inside. But before that, we do have one more beam at 1.5 meter distance from this end. So we need to create that beam. Go to property, just select that beam and copy, select copy and select paste beams. After giving right click, in X direction you need to give 1.5 meters. Since our direction is X, towards we want this side, since it is towards this side, we'll give positive and 1.5 meters in this way. You can view it in 3D view too. Everywhere the beam is created. Go to top view. Now you can assign load 6 kN per meter to inside walls. Select the walls. As you can see it. Assign to selected beams. Assign. Once the loads are assigned, now you can go to design. So first, concrete. Select the proper IS code. As for me, it is IS 456, and I need to define some parameters, particularly compressive strength of concrete, which is 30,000 kN per meter square for M30 grade, and grade of steel will be 415 000 kN per meter square. Secondary reinforcement also of same grade, and give the maximum area of percentage of reinforcement as 3%. Now we need to define few commands, particularly beam and column. Design beam add, design column add, take off. So we select first M30, FC30, assign to entire structure. Similarly, FY main. Similarly, secondary reinforcement. Similarly, the percentage of steel. Coming to design beam, we need to design beams parallel to X and beams parallel to Z. Coming to columns, beams parallel to Y. Yes. Once this is over, you can go to analyze and print, add, close, analyze, run analysis, save. This might take some time to analyze, but once the analysis is completed, you can go to post processing mode to view the deflection, shear force, bending moments, whatever you require. As you can see, so you can obtain reactions at columns by going to reactions tab, and to obtain the displacement animation, we go to animation tab, select section displacement, we select apply. Okay, you can view the displacement for dead load, for live load. Press escape to leave it. So this will be the end of the session. In next session we will be dealing with wind load analysis, later on with earthquake analysis, and later on with slab elements design and reports and many more things. So please subscribe to this channel to learn lot of things. Thank you.